This is 13.2, Standard Form of Ellipses and Hyperbolas with Sophie. Here we're going to be learning the difference between ellipses and hyperbolas, equations and formulas. So we're going to start with this first one over here. And this is an ellipse because of the plus sign, and we're finding a major and minor axis. So the most common way that you can tell that it's an ellipse is with the plus sign. So a hyperbola will be with a minus sign. Okay? So right now our center is 0, positive 1, because x squared represents 0, there's nothing there. Okay, so 0, positive 1 is our center. And we're looking for vertices, co-vertices, foci, major axis, and minor axis. Okay? So let's graph this real quick. 0, 1 is right there. Okay? And with that, we need to find our vertices. So this is A and this is B. And what those represent is how long, which way, the direction that it goes, and how wide it is and how long it is, okay? So in this case, it runs horizontal because x is bigger. If y was bigger, y would be in front and it would run vertical. It would run vertical. Okay? So the square root of 36, let me write down this equation for you real quick. X minus h squared over a squared plus y minus k squared over b squared equals 1. Okay, that's the standard ellipse equation. And so what that will look like on here is 36 squared, or the square root of 36 equals 6, square root of 25 equals 5. So right now we go 6 in the x direction, so 1, 2, 3, 4, 5, 6. Let's count that again. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Okay? So that's how far wide it runs. So this is the major axis, okay? And we can label that major. Alright? And then we can go 5 up and 5 down. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? And this is the minor axis, so let's label that minor. And these are your vertices because they run lengthwise. These are your co-vertices, okay? So whichever one is longer are your co-vertices. Or whichever one is shorter are your co-vertices. So let's label that V and CV. Okay? So now we can draw our ellipse and what it'll really look like. And an ellipse is really, it's like an oval. It's just a stretched out circle. Mine kind of looks like a football, but whatever. Okay? And it's not really what they look like. They're more round, I guess. I don't know. But, so here we want to say what our vertices are. So right here they are negative 6, 1. So we'll write that down, negative 6, comma 1. And positive 6, 1. Okay? And then for our minor axis, or for our co-vertices are 1, 2, 3, 4, 5. So 6, 0, 6. And 0, 4. And that's the point that these lie on, okay? And they should always be whole numbers, and if they're not, you should have a really detailed graph whenever, if that's given to you on a test or a paper or whatever. Okay, so next we can find our foci, and this is our formula to find our foci, and it kind of looks like the Pythagorean theorem formula, but it's not. And note that this is different than this formula right here, which is our hyperbola formula, okay? And the hyperbola formula is the Pythagorean theorem formula. So way to remember the differences is they're opposite. So whenever I have an ellipse, it's a plus here, but it's a minus here, okay? So that's a good way to remember it. And the same for hyperbolas. Whenever I have a minus here, it's a plus here. Okay? So that's just an easy way to remember it. So for our foci, we should have a squared minus b squared. So 36 minus 25 equals 9. No, equals 11. Just kidding. 11. And then we're going to have the square root of 11. The square root of 11 is roughly equal to, one second. The square root of 11 is, we need a rough guesstimate of what it is. So, but whenever we write that down for our foci, we need the exact. So the square root of 11 is somewhere between 3 and 4. So because we can't really graph this exact, we're just going to say 3.5. Okay? So about 3.5. So this is going to be on your major axis. So 1, 2, 3.5. This is one focus, and then 1, 2, 3.5, another focus. Okay? So that's where your focus lies. And with that, we need the exact coordinates. So we need to put this in square root form of our focus. So because we're going in the x direction, we're going to write this down like that, okay? So it's just going to be the square root of 11, 1, and then because square roots come in pairs, I think we learned that in our last chapter, because they come in pairs, we need to make sure that we have negative square root 11, like we do right here, okay? Plus it goes on the other side, so foci come in pairs, okay? And then in a case like parabolas, there's only one focus. Alright, so all we have left is the major and minor axis and how the length of those, so we'll put L here just to make sure that you know it's the length of the major and minor axis. Okay, so for this, it's super simple, you just have to count them. And it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our major axis is 12 units long. Our minor axis is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units long. Okay. Another way that you can do that is 2a and 2b. Okay. So whenever you do the square root, it's just 6 times 2 and 5 times 2. Whatever the a and b's are. Okay. So take a minute to write all that down. Get that lined up. Next we're going to be doing our hyperbolas, and a hyperbola is basically a backwards ellipse, if you want to think about it that way, or it's a mirror image of a parabola. Okay, so you want to get a ruler for this. I have a ruler because we're going to be needing it to find our asymptotes. Okay. So, for a hyperbola, we need to find our vertices. Right? Yes, our vertices, okay? So we need to find, this is our center, is 0, 0, which is really, really rare. So because y squared and x squared represent 0, it's just 0, 0. It's really fortunate for us. Okay? So then we have to do the square root of each of these to find which way we're going, up and down, and we're going to draw a box, okay? So for y, we're going to go 1, 2, 3, 4, 5 up, and 1, 2, 3, 4, 5 down, okay? And this box doesn't really represent the graph. It's not even on the graph technically, but we still draw it just so we know the general direction that we're going. 1, 2, 3, 4, 1, 2, 3, 4, okay? So now we can draw our box and then do a dashed line just to make sure that we know it's not an actual part of the graph. Okay. Alright, so this is our box, and our parabolas are going to go on the outside of this, on the outside of that. So we should draw our asymptotes, and this is where your ruler comes in handy because we're going to be going diagonal. Okay, so make sure you line up the corners and then it passes through the center of your graph. It doesn't really pass through the center, but it's okay. Alright, once you line up the corners, then your graph will go, your parabolas will go on either side of these asymptotes because it cannot cross the asymptote. That is something that we learned, I think, in the beginning of Algebra 2. Alright, so your vertices are at 0, 5, and 0, negative 5. So that's going to be on the y-axis because y is bigger. Okay, so write that down at 0, 5, 0, negative 5. Okay? Next we need to find our foci. So the thing to remember about foci for ellipses and foci for parabolas is that the foci and the ellipse will be inside the ellipse. And foci for parabolas, or hyperbolas, because it is like a parabola, they'll be outside. They'll be inside the your little dip. It's right here, but they'll be outside this little box. Okay, so they'll be inside. This is where your focus is, and this is where your hyperbola is, and then you'll have another side like that. But they'll be outside your box, so that's a nice way to remember. That's why we're adding them, because it's going to be bigger than your box. So 25 plus 16 equals equals 41. The square root of 41 is about 6.4. Okay? Remember that we're adding these because it's the opposite of the hyperbola equation. And let me write that down for you. It's x minus h over a squared. The nice thing about hyperbolas is that a normally comes first, but a can be either x or y, whereas it is different for ellipses. Okay, and then all of these equal 1. So these equations look very, very similar, but they're not, because this is subtracting and this is adding. Okay. So our 6.4, so about right, 6.4, about right there. Okay, so that's where our focus is, and so we want to write that down as 0, negative 41, negative square root of 41, and 0, positive square root of 41. Alright, so our asymptotes are just simple linear equations. Alright, and so we're going to do, y equals mx plus b, so let's write that down as equals mx plus b, which was what we learned in Algebra 1. I spent like 3 months on it. So, from this corner, right here, which is 1, 2, 3, 4, 5, 1, 2, 3, 4, which is 4, 5, which is where this is. We're going to go up 4, or up 5 over 4, which gives us a 0, 0. So our equation will look like 4 over 5x, okay? Then our other equation will be negative 4 over 5x, because those are the opposites, and it intercepts the y-axis at 0, so we don't have to worry, so it's just plus 0, we don't have to worry about putting that. And the direction that these open up is determined by the focus and the length of the major axis, which is y. So they open up and down. And we're just going to follow the asymptotes as we graph this, okay? So we start at the vertex and we graph that way. Alright, so that's the direction that they open up, which is vertical. Okay, make sure you put all those down. Next, I think we're going to be doing general form of an equation. No, completing the square, I'm sorry. Next, 13.3 is completing the square, which is going to be needed for our unit after that, which is general form. Okay, so that's ellipses and hyperbolas. If you want to write that down, you can pause the video. Thank you for watching.